grade, and welcome to our screencast on numerical expressions. Our objective is I can write and interpret numerical expressions and compare the expressions using a visual model. To review, expressions are when we have math sentences without equal signs. So for example, 4 plus 2 is an expression, but 4 plus 2 equals 6 is not. When you have an equal sign, that is called an equation. So there are no equal signs in our lesson today. Let's start off with an estimating review, and we'll be estimating products. So that means when we're multiplying two numbers, we have to find the answer to the multiplication question, and we want to estimate to see around where our answer should end up. So it helps us to make sure that we're being more precise in our answer and accurate. For A, 421 times 18, I'm going to round to the nearest hundred and then the nearest tenth. So 421 is closer to 400 than it is to 500, and 18 is closer to 20 than it is to 10. I know my basic facts, so I can do 4 times 2 is 8, and then count my zeros, 1, 2, 3. So our answer should be somewhere around 8,000. For B, 323 is closer to 300 than it is to 400, and 21 is closer to 20 than it is to 30. 3 times 2 is 6. And I have 1, 2, 3 zeros, so our answer should be close to 6,000. If I got an answer when I multiplied that was 800 or 600, then I know I'm a little off. And C, we have a number that is close to 2,000. So we'll start off with 2,000, and I rounded to the nearest thousand. Times 42, well, that's closer to 40 than it is to 50. 4 times 2 is 8, and then my zeros, I have 1, 2, 3, 4. 1, 2, 3, 4. Okay. Another strategy that we're reviewing is using the distributive property to break up or decompose factors. So let's just go through this together. 9 times 3 is the question that they're asking us. They don't know what is 9 times 3. Instead of just memorizing this basic fact, you can break 9 times 3 up into 5 times 3 plus 4 times 3. Because 5 plus 4 is 9, and you're still multiplying each of those by 3. So I know 5 times 3 is 15, and 4 times 3 is 12. And if I add 15 plus 12, I get 27. All right, so we can use that strategy to practice a couple problems. You can break 7 up into any two numbers that when you add them, they equal 7. I could do 6 and 1, 2 and 5, 3 and 4, whichever facts that you know to multiply. So I think I'll do 6 plus 1. Now I'm doing 6 times 4, and I'm adding that to 1 plus 4. That would give me 24 plus 4 equals 28. For B, you can break this up into whatever you want as long as it equals 8. So I think I'll do 4 and 4. So now I'm doing 4 times 2, and I'm adding that to 4 times 2. I know 4 times 2 is 8, and 8 plus 8 equals 16. Okay, for C, I have 9 times 6. I think I'll break it up into 6 and 3. 6 plus 3 is 9, and I'm still multiplying each one by this 6. So 6 times 6 is 36. And 3 times 6 is 18, and when I add those, I get 54. So this is just another strategy that you can be using to break down your multiplication facts instead of just memorizing the facts. Let's do an application problem. Make sure you write this out so you have the example in your notebook. Robin is 11 years old. Her mother, Gwen, is 2 years more than 3 times Robin's age. Our question is, how old is Gwen? So the numbers I see are 2 and 11 and 3, and the question is asking us how old is Gwen? And I see 2 operation words, more or more than, and also times. The information I know right away is that Robin is 11. So I drew a tape diagram, a little box that shows 11. And I put an R to represent that this is Robin. I know that Gwen is 3 times Robin's age plus 2 more years than that. So I drew a tape diagram for Gwen showing she's 3 times what Robin is plus 2 more. And that total tape diagram, I put a question mark because that's what I'm trying to find out is how old is Gwen. Now this helps me because I know if this is 11, Gwen is 3 times that, so she would be 11 plus 11 plus 11 plus 2 more years. If I show that with a math sentence or an equation, I would be doing 3 times 11 and then adding on 2. The reason why I have to put parentheses around 3 times 11 is because I have to do that first before I add the 2 in order to get the correct answer. So when you put the parentheses, it says you have to do this step first. I cannot add 2 until I get this product. So 3 times 11 is 33 plus 2 is 35. So Gwen is 35 years old. Okay. Let's do some more tape diagrams. And we'll start with this chunk up here. We're going to look at how we can take an expression given to us and make sense of it in word form and with tape diagrams. So this one says 3 times 5. In word form, I could write that out as 3 times 5, or 3 multiplied by 5, or 5 groups of 3, or 3 groups of 5. There are a whole bunch of different ways that we could write that in word form, but we'll stick with 3 times 5 for now. And I'm showing that I'm taking 5 and I'm giving you 3 groups of it. So this is 5, this is 5, and this is 5. So now I could add 5 plus 5 plus 5 and get an answer. For the next expression, instead of a number, they gave us a letter. So when you have letters like this in math, it's kind of the beginning of basic algebra, where the letters can stand for any number. So I could say, solve this expression when a equals 0, or solve this expression when a equals 10, and that means you would just plug in a number for where you see the letter a. So if I said a equals 0, then this would be 3 times 0 is 0. But if I said a equals 10, then this would be 3 times 10, and I would plug in tens. So a could represent anything, but if I were to write this in word form, it would be 3 times a, or 3 times the letter a, or 3 groups of a, or 3 multiplied by a. And our bar diagram would look pretty similar to this one, except instead of an actual number, I just put a until we know what a equals. This expression just stays as 3 times a. And this tape diagram looks very similar to the 2 above it that we just did. However, the quantity or the value of each box is 26 plus 4. So this first box is 26 plus 4. The second box is 26 plus 4 then, and then the third box is also 26 plus 4. So as an expression written out, I would take 26 plus 4 and then find that 3 times. Or I could write it this way, kind of flipped around, 26 plus 4 and then times 3. And remember we talked about why the parentheses are there? It's to show us that we have to do what's inside those parentheses first before we multiply by 3. So I can't just start solving this by saying, okay, 4 times 3 is 12 and 26 plus 12. No, I have to do what's here first. So 26 plus 4 is 30, and 30 times 3 gives us the answer. Up here, it's the same thing. 26 plus 4 is 30, times 3 gives us our answer of 90. So in word form, I would have to show that we have to do this first. So I could say we're adding, so I'm going to find the sum of what's in here first. So I'll say the sum of 26 and 4 multiplied by 3. Some people might write this out starting with the 3, like 3 times the sum of 26 plus 4. So when you're writing out expressions in word form, there's often more than one way to write it out. All right, and then B is showing us one that's a little bit longer, 6 times the difference between 60 and 51. So this time they gave it to us in word form. And I know if I'm finding the difference, I'm subtracting. 60 minus 51 and then they want 6 times that difference. So I could write maybe 6 times at the beginning, or I could show that I'm subtracting 60 minus 51 first with my parentheses, then I'm multiplying that by 6. So the times 6 can go on either side. So here's my 6, ready? 1, 2, 3, 4, 5, 6. Each one of these boxes then shows 60 minus 51. I'm finding the difference between those two numbers, and then I'm showing that difference 6 times. So I know 60 minus 51 is going to be 9, and they want me to show that 6 times. So to figure out the value of our entire tape diagram, I now could do 6 times 9. Okay, and then before we do C, you're going to notice I gave you a little note here. These two answers, which I just repeated, these two answers here in black, these two expressions are equal, and that's because of something in math called the commutative property. The commutative property tells us that when we multiply, it doesn't matter which order we're multiplying in. That's why you could put your 6 here or here. Just like it doesn't matter if you do 4 times 3 or 3 times 4, you're still getting the same answer. So that property is called the commutative property. And then let's do one more tape diagram example. The sum of 2 12s and 4 3s. Well, the sum of that tells me that we're adding 2 things. So I set up parentheses that are blank on the inside so that I remember I have to fill these up, and I'm adding them. What am I adding? 2 12s, so 2 times 12, and 4 3s, 4 times 3. If I were to show this with my tape diagram or my bar model, I have 2 larger boxes and 4 smaller boxes. In my 2 larger boxes, I'm going to write 12 and 12 because I'm showing 12 2 times, and then I'm showing 3 4 times. So now I could multiply or add all these together. 12 times 2 is 24, and add 24 to 3 times 4. Or I could do 12 plus 12 is 24, plus 3 is 27, plus another 3, plus another 3, plus another 3, until we get our answer. Okay, and then finally, you might be given some problems that look like this. So we'll start with these problems up here, and then we'll compare them to end our lesson. The 3 problems up here are expressions that we need to put into word form. So they don't have equal signs. So in our expressions, we'll never use the word equals. I see parentheses here, so I need to write in my word form that we need to do this first. So the difference, because we're subtracting, I'm going to say the difference of, and then you always say the bigger number first. The difference of 43 and 13 multiplied by 8. We have to start with what's in our parentheses here. The sum, I'm saying sum because they're showing me that we're adding, of 16 and 9 times 4. And then finally, I'm adding here, but I'm going to start with what's in this first set of parentheses. The product of 20 and 3 added to the product of 5 and 3. So like I said before, there are many different ways that you could write this answer. So the way that you write your word form might be different than the person next to you. You could have started out here by saying the sum. Okay, and then finally, we have some expressions here at the bottom that we need to compare using symbols. So we have the less than sign, the greater than sign, and the equal to sign. And they gave us two expressions that we need to compare and show which expression is larger or which one has more value or smaller, or are they equal. So when they give us two expressions, a way that you could figure out which one has more value is by drawing the diagrams. So this first expression, 9 times 13, I showed you 13 9 times. And then the second one, I showed you 13 8 times. And from this model, I can clearly see that this one is bigger. So I'm going to open up my comparing sign toward the number that is larger. So the product of 9 and 13 is larger than the product of 8 thirteenths, or 8 and 13. Using that visual model really helped me to see that there's an extra piece up here that makes it larger than this one. And then our last problem, we're comparing two expressions. The first expression is the sum of 10 and 19 doubled, and then we're comparing that to the sum of 2 times 10 and 2 times 9. Okay, so I have the sum of 10 and 19. That would be like adding 10 plus 19, but they're doubling that, so they're doing it 2 times. 10 and 19. Here they're showing me 2 times 10, and then they're showing me 2 times 9. So just by looking at this, I can tell this one is larger because I have 10 and 10 in both of them, but then I have 19 and 19, 9 and 9. And I know if I'm adding all these numbers together, this will have a greater value. Thanks so much, 5th grade.